name's Russell Hughes from Sunset Learning, and I'm here today to talk about route maps and configuring route maps on Cisco IOS. So it's kind of hand in hand with what we were talking about before within access lists. Access lists and route maps are very, very similar with each other, and as a matter of fact, quite commonly used with each other, as a matter of fact. So we'll go through to discuss route maps, and route maps are really kind of, I always think of them if-then-else statements, if you will. Okay? Very similar to a scripting language, if-then-else statements that we have. They work very similar to an access list. However, they're more sophisticated. Access lists allow me to match certain types of traffic. That's about it. You either permit or deny it based off that matching criteria. In a route map, not only can I permit that traffic, but then I can set information on it as well. I can tag routes in the routing protocol. I can go through and set attributes in BGP. We can go through and do things such as setting an outbound interface or setting a next hop IP address within here with what they call policy-based routing. So not only do they allow us to match and permit and deny, but we can also then set certain things within here. They show very similar to access lists in the fact that they do top-down processing. We start with the lowest sequence number and work our way to the top. Okay? When one of our statements is a match, we stop checking the rest of that access list. Again, very similar to a route map, very similar to an access list. We get to see each one of our lines going to be actually sequenced. The sequencing allows me to go through and insert different lines and allows me to delete a specific line or edit an individual line. They show all route maps are named rather than having a number, much easier for documentation purposes that we have. Like we said, our match criteria and set criteria can be used, so it's similar to that if-then-else kind of logic and scripting language that we have. So, quite a few different applications that we can use route maps on as well. Okay? As they show, we can do it as we're dealing with redistribution of routing protocols, allowing us to say, I want to learn traffic or learn routes from EIGRP and inject that traffic into OSPF, or all those routes into OSPF. I might want to do some filtering within there as well. I want to inject routes, but not all my routes, just certain routes into OSPF. Okay? So we can go through and utilize an access list at that point in time. A lot of people also allow us to utilize things such as route tagging as well. I can tag certain routes. People use route tagging to be able to say, hey, if I tag routes in OSPF, I want to redistribute those routes in BGP, so I can advertise those routes out onto a service provider. We have things like policy-based routing. Now, policy-based routing allows us to change our routing behavior. Normally, in a normal certain situation, a router looks at the destination IP address of a packet and determines what route in the routing table is our best path to get to that destination network. In policy-based routing, it allows us to route on things other than the destination IP address. I can match the source IP address. I can match information like what application is it itself with protocol and port number information. And I can say, even though it's not the best route, I want certain types of traffic to utilize as secondary route. Okay? We see a ton of route maps being used in BGP. As a matter of fact, when they originally implemented route maps, it was for BGP and purposes in BGP. Most of the set conditions that we have in route maps allow me to set different BGP route attributes, doing things like AS-path prepending, or sending out community strings in BGP, or matching community strings and setting local preference. Lots of different things that we're utilizing route maps for in a BGP type of policy implementation. So when we look into route maps, as far as our operation is concerned, they show it's a list of statements that constitutes a route map, just like we saw in an access list. Okay? So we'll have a route map and the name of our route map. You'll have either a permit or deny statements that we have, and then we'll have sequence numbers. So all of these being a part of the exact same route map name would be different sequences in that same route map, or different statements in there. They show the list is processed in a top-down manner, just like an access list. So I'm going to evaluate that packet to see does it match the first statement in the route map. If it does, I'm either going to permit and deny based off of what they show over here. And like we said, we can also set different attributes about that particular packet as well. But I would stop checking the rest of the route map. No need to check the rest of it because I've already matched a statement. If it doesn't match that statement, on to the next statement in the route map. Okay? They show the sequence number is used for inserting or deleting specific information. We mentioned the idea of an access list having an implicit deny all. Route maps are very, very similar to that. If you do not permit it in a route map, it is going to be denied by default. Now, in a route map, we have match statements. And these match statements can contain multiple references. Typically, you're matching an access list. Okay? And they show a couple different things. We can have one match statement that matches multiple access lists. And if that's what you're doing, it's a logical OR. It could match this access list, or this access list, or this access list. If I use that, however, in multiple conditions, multiple statements, and in this case now they're saying it has to match access list number 1, and come in from interface Ethernet, fast Ethernet 0/0, and have a metric of 3 for it to match a specific statement in the access list. Okay? So with multiple match conditions like they have here, written in separate statements, it's a logical ANDing process that's being used. As far as configuring a route map, very similar to what we have to do within an access list. I have to build it in global config and then apply it to an interface or apply it to a routing process that we're going to use. So we have to find out what we're going to have for match conditions, typically utilizing things like an access list, a prefix list, an inbound interface that might potentially be used. I then have to define what are we going to match, and then what are we going to do with that particular traffic. So those set statements and what actions can be taken on that match. And then eventually apply that route map to an interface itself. So they go through in global config, and I create my route map. You type in route-map, and then the name of your route map, which is case sensitive, and then either permit or deny, and our access list or our route map statement number. Okay? Now, if you do not put in a sequence number itself, they start at 10 and work their way up in values of 10. That would then take you underneath the configuration of that route map, a subcommand mode, where we eventually then start to use match conditions for this. So I can specify, in this case, match an IP address, and then I can specify that is a prefix list named my list. Okay? It could also match an IP address of an access list name. Eventually, then we also have set conditions. What are we going to do? In this case, it says, let's set the interface to be Ethernet 0. So anything that matches this prefix list is going to go out interface Ethernet 0. I eventually then have to apply that to an interface. And this is what they would consider to be policy-based routing in this case. So I've gone into an interface and said, IP policy, route-map, my route map. Okay? And applied the name of that route map to that individual interface. So they give us kind of an example right over here of creating that route map and going through and utilizing it to affect traffic. So what they've got is I've got access list number 25 down over here. Okay? So they created access list number 25 first, where they're permitting traffic from the 10.10.8.0 subnet. Okay? I got an extra dot in here on my slide, but so from the 10.10.8 network and from the 10.14.0 subnet that we're matching within here. Okay? So if it comes from one of those two subnets. They then created my route map. My route map, called my route map in this case, says if it matches the IP address of access list number 6 or access list number 25. So access list number 6 permits the 172.16.29 network. Access list number 25 permits the 10.10.8 and the 10.14.0 network. So if it comes from any of those three networks, we will set the next hop IP address to be a 172.21.16.18. Okay? So if it comes from any of these three subnets, it goes out to this particular service provider. Okay? I eventually apply that route map on my interface serial 0 in this case. So they say IP policy, route map, my route map. So any traffic that comes in on interface serial 0 that has one of these source IP addresses within here will go to this as the next hop IP, regardless of what the best route in the routing table actually is. Okay? We're going to do policy-based routing before we ever get into a routing protocol. And so that's pretty much exactly what we've got for route maps. Okay? Stick with us. So again, we'll come back and we'll do volume 3 or our third part using VLAN access maps.